Hello, welcome to Chapter 2, homework questions 59 through 62 in Core Connections Algebra. Question 59, find the rule for the following tile pattern. So you have figure 2, 3, and 4. Let's figure out how many tiles are in each of these. So we have 1, 2, 3, 4, 5, 6, 7. So 7 tiles. And then you have 1, 2, 3, 4, 5, 6, 7, 8, 9. So it looks like 2 tiles were added. And it looks like it was these 2 that were added. Same thing on 4. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And once again, if you're paying attention, these 2 were added again. So you can see there's always 2 added on to the right-hand side. What would figure 1 look like, or at least how many tiles would be in figure 1? If we're adding 2 to go in this direction, we keep adding 2 tiles. Then to work backwards, we would subtract 2. So in figure 1, there would be 5 tiles. And then on figure 0, because we want to know where it starts, what that initial is, so you go back again, and that would be 3 tiles. So at figure 0, we would have 3 tiles. And even if we don't know what it looks like, we still have the information we need. We need to know what figure 0 is, and we need to know what the growth is, and we can write a rule or an equation. So y is equal to, it's growing by 2 each time, so it equals 2x, and we start at 3 tiles at figure 0. So here's would be your rule or your equation for the tile pattern. Question 60, copy and complete the diamond problems below. The pattern used in the diamond problems is shown to the right, so you remember that on top we're multiplying the x and y, and on bottom we are adding the x and the y. So on A, we're not given x and y, we're given the y and then the product, so we're looking for x. So the question is, what is negative 1 times x would be equal to negative 4/3? So if you divide by negative 1, that's just going to give you x as a value of a positive 4/3. So does it make sense when I take positive 4/3 times negative 1 to get negative 4/3? Yes, and you could have done that without writing the equation, but that equation is always there if you need it. Now that we have x and y, we should be able to take 4/3 plus negative 1. And once again, you can do that on a calculator, you can do it in your head, you can create a common denominator, however you want to approach that. I'm going to go ahead and create a common denominator just so we can see. So multiply top and bottom by 3, so negative 3 over 3 is the same thing as negative 1. So 4/3 plus negative 3/3 is 1/3. D, now D we are given x and y, so we just need to multiply negative 3/5 times negative 4/5. We can multiply straight across. Negative times negative is a positive. 5 times 5 is 25. So the product is 12/25. And then the sum, negative 3/5 plus negative 4/5. Add the numerator or the numerators because the denominator is the same, and so you get negative 7/5 for that one. All right, C, now we're given the sum of a number and negative 1/6 to get 1 and 5/6. So I'm going to change the 1 and 5/6 to improper. So 1 is 6 out of 6. So if you add that to 5/6, that will give you a total of 11/6. So here's the number for the bottom. And I have negative 1/6, negative 1/6 plus some number should give me 11/6. And if you do it that way, you might be able to figure out, negative 1 plus what's going to give you 11, and that would be 12. Or you can solve the equation by adding 1/6. 11/6 plus 1/6 is 12/6, which reduces to 2. So now we know x is equal to 2. And then to do the second part, which is the multiplication, 2 times negative 1/6. Remember, 2 as a fraction is 2 over 1. So if you want to write it that way, that's fine. Multiply straight across. 2 times negative 1 is negative 2. And then 1 times 6 is 6, which then can reduce to negative 1/3. All right. And on the next one, we don't have an x or a y value. So how are we going to do this one? We're really trying to answer this question. X times y, what number times another number gives you 1/6. But what also, when you add those two numbers, those same two numbers, you're going to get 1/2. So see if you can think about that. What multiplies to give you 1/6 but adds to give you 1/2? And one thing that we could do is we have 1/4 plus 1/4 would be 2/4, but that reduces to 1/2. And then to get the 16, what I was thinking was, what times something to get 16, and 4 times 4. So 1/4 times 1/4 is 1/16. We had some other options like 1/8 times 1/2, but that wouldn't add to give you a half because you're already using the half there. You could have also possibly tried, I guess only the 1/16 and 1. But once again, that's going to be bigger than the 1/2, so those wouldn't have worked out. So it looks like we found the answer. It doesn't matter which one's x and which one's y, so we have, I guess they're the same, so it wouldn't matter anyways. But it doesn't matter where you place those, because what multiplies to give you 1/16 and also adds to give you 1/2. Question 61. This is heat 3 of the big race, so this is a continuation of what we did in the core problems. Heat 3, Barbara, Mark, and Carlos participated in the third heat of the big race. Barbara thought she could win with a 3-meter head start, even though she only pedaled 3 meters every 2 seconds. Mark began at the starting line and finished the 20-meter race in 5 seconds. Meanwhile, Carlos rode his tricycle so that his distance y from the starting line in meters could represent the equation y equals 5/2 x plus 1, where x represents the time in seconds. So you're given all three of the contestants or participants in their race or whatever. So you have all the information for Barbara, Mark, and Carlos. Part A, what is the dependent variable? What is the independent variable? So remember, the dependent variable is your output or your y, and the independent variable is your x. And right here, as we read, it said x represents the time in seconds. So the independent variable is the time in seconds, and the dependent variable, which would be your y value, would represent the distance. And how is the distance measured? It's measured in meters. B, using the given information, graph lines for Barbara, Mark, Carlos on the same set of axes, and who won the 20-meter race and will advance to the final race. And so we could have graphed these, and I have a graph below. C also says find the equations that describe Barbara's and Mark's motion. So we can do these kind of in whatever order we want. But here's I just went ahead and copied what was in the answer key, so you can see the 3 different lines. You have Mark, Carlos, and Barbara. You can see the distance is your dependent and the time is your independent. Depending on where they started is where you'll see them on the y-axis. And then remember, the race is 20 meters, so at 20 meters, who finished first? So as you go across here, who had the better time. And so that's what you're looking to do in terms of part B, is to graph the information for all 3 of them. Make sure you label, and then also it does say who won the race, and in this case, Mark won the race, and you can see that in terms of his time there. On part C, write the equations for Barbara and Mark. So going back up, looking at what Barbara did. Barbara thought she could win with a 3-meter head start, even though she only pedaled 3 meters every 2 seconds. So Barbara's equation, her rate of change is 3 meters every 2 seconds, so that would be 3 over 2 x, but she is getting a 3-meter head start, so that would be plus 3. Whereas Mark began at the starting line, so he didn't get any head start, but finished the 20-meter race in 5 seconds. So if he finished it in 5 seconds, how fast was Mark going? Well, if he was going 4 meters, 20 divided by 5 is 4 meters every second, he would have finished in 5 seconds. So Mark's equation would have been y equals 4x. I'm going to put a plus 0 just to show you that he was starting at the starting line, so he didn't get a head start. On D, how fast did Carlos pedal? Write your answer as a unit rate. So let's go back up here. Carlos rode his bike so that his distance from the starting line in meters could be represented by this equation. So how fast was he going? What was his rate? 5 over 2 which represents, well, let me write it this way first. So 5 over 2, but we want it as a unit rate, so we want it divided by 1. So if we take 5 divided by 2, that's 2.5. And how fast is that? Well, that's your rate of change. It's over 1. So 2.5, your y value is meters. Your x, so y is in meters, x is in seconds. So that would represent 2.5 meters per second. And that's what we call unit rate, where it's over 1. And then part E, when did Carlos pass Barbara? Confirm your answer algebraically. So you can see on the graph where Carlos is somewhere passing Barbara, but where does that occur? So when we graph this a little bit more accurately than what you're seeing on here, you'll notice that Carlos is behind, but then at time 2, so in 2 seconds, you are at 6 meters. So where they intersect is where that occurs. So when did Carlos pass Barbara? After 2 seconds and after 6 meters. So it happens at, time and distance is what you're looking at. And so I said 2 seconds after the start of the race and 6 meters from the starting line. Question 62. Create a table and a graph for the line y equals 5x minus 10. Find the x and the y-intercept in the table and on the graph. So to be sure that we find the y-intercept, we can plug 0 in for x, which I have on the table. I also plugged in some negative numbers and some positives, or put some on the table. And then now I'm going to plug them in and see what we get. So y is equal to 5 times negative 2 minus 10. So that would be negative 10 minus 10. And that's negative 20. So that won't fit on the graph, so I'm going to go ahead and do the next one and see what's going to happen. And remember, this is linear, so we should see a pattern with our y values. So now negative 5 minus 10 is negative 15. So it appears that the y's are going up by 5. Let's go ahead and do one more just to verify that. We'll plug in 0. And we get 0 minus 10, which is negative 10. Since we know it's linear, we can go ahead and just keep adding 5 each time. So the next one would be negative 5, 0, 5, and 10. And if we graph those points, we have 0, negative 10. I didn't graph the first two because they don't fit on the 10 by 10 coordinate plane that I have. 1, negative 5. 2, 0. So there's the x-intercept. 3, 5. And then 4, 10. So we can graph it. You make sure you use a straight edge. And then we also can identify both from the table and the graph. So here is the x-intercept at 2, 0. Here's the y-intercept at 0, negative 10. And then from the table, you see the y-intercept and the x-intercept. So this one right here is the y-intercept when x is 0. And then this one right here is the x-intercept when y is equal to 0.